Okay, hello. My name's Hauenstein, and I was assigned homework number 1, problem number 12. And right here, I already have the problem written down. The problem states the displacement of the wave traveling in the positive x direction is dxt equals 3.5 centimeters sine 2.7x minus 124t, where x is in meters and t is in seconds. What are the A, frequency, B, wavelength, and C, speed of this wave? So first of all, I'm going to write down my givens. So just going to label given, nice and clear right there. And the formula that we are given is dxt equals 3.5 centimeters sine 2.7x minus 124t. So that looks like one of the formulas we were given. dxt equals A, which is amplitude, sine the k x minus omega t plus the phase constant. So with this formula that we have already established in the class, you can already pinpoint and label all your other givens based off this formula. So for example, your amplitude is given here as 3.5 centimeters, and your k is also given here, which is after the sign right in front of the x, which equals 2.7, which comes in as rad per meters. Always write your units after. And then you're also given your omega, which is 124. As you can also see, it's in front of t. So 124, that comes in rad per second. And then your phase constant is going to be equal to 0, since you don't have it existent in the initial formula. So with that given, the initial part we're going to be looking for is part A, frequency. So with that being said, A, what formulas that we have for frequency? One of them is frequency equals omega over 2 pi, and given omega here equals 124 rad per second over 2 pi. So I already have the values written down on the side over here, so I know what this equals. You can just plug this into your calculator and you're going to get 19.7 hertz, and hertz is basically frequency, which is just 1 over seconds, and this is approximately equal to 20 hertz. So that is your frequency. You can just draw an arrow here. F equals 20 hertz. Box that up real quick. That's part A done. So you can move on to part B, which you're finding is the wavelength. So you can just start on a line, give it some space so it's nice and clear. Formula that we have for wavelength. Wavelength is equal to 2 pi over k. It's another formula we're given on our equation sheet, and we have k based off the formula. So we can just make this equal to 2 pi over 2.7 rad per meter. And again, I have these already calculated and written down on the side. So for this, it is going to equal 2.33 meters, which is simply written 2.3 meters. So just draw a little arrow for our final answer. Lambda wavelength is going to equal 2.3 meters. Box it up for that answer to that section. And one more part, breaking down the question, you have part C, which is what is the speed of this wave? And that is simply, you can just use the two values that you were already given for the speed, velocity equals lambda times frequency, and it's just simple plug and chug. You have lambda, which is 2.3 meters, and you have you have your frequency, which is 20 hertz, and you're just gonna write 20 hertz, which hertz is also 1/2, which matches up with your velocity, which is going to be meters over seconds, and this equals roughly 46 meters per second. Draw a little arrow, and then you will have your speed equals 46 meters per second. Box that up, and that's the complete part. You went through the problem, broke it down, you found out your given equation, you matched that to one of the given equations that we had in our equation sheet, and then you go back through, you list, okay, what am I given? And you're able to point out the different parts as I did at the beginning, and then you go, okay, well, what is the question asking me? And you'll say, okay, it's asking what are the frequency, wavelength, and speed of this wave. So you break down the question, you find your given, and then you go step by step, find the different variables, and then you can calculate for your answer. Yeah.